Hey guys, so now we are ready to start doing the useState hook. So the first thing is we wanna tackle this branch. So when we have a functional component, and what we wanna do is let's start with the client side. So what we wanna do ideally is something like let's create a counter component. So counter. And the counter will be up here. Const counter will be props, and what I want to do is simply return a div, and in that div we will have a button which will have the increment stuff, and a div where we will render something. So yeah, we have the increment, nothing happens at the moment. So ideally the API is, according to the React docs, is something like value and set value equals useState, and let's start with 0. Obviously it will throw a bunch of errors. useState is not defined, so useState will be coming from here. useState, so React export use state from and create hooks directory just here, new file index.js, and let's just export useState, export const useState equals initial state, and it will return an array with some function. I think that will work probably. Yeah, okay. So now we have it running, so we have the value and we have the useState, so we can replace this with the value, and we can attach an onClick here. So onClick will be set value and value plus 1. So that's the API. If we were to copy paste the whole thing and put it to normal React, it would work. I mean, I kind of expect it to work. We don't have any props, so we can get rid of it. Okay, and we can click on increment, nothing happens obviously. Okay, so far we did nothing, we just created a dummy implementation. Okay, how to proceed from here is a good question. So we have the reconciled children, and we need to do some magic here, right? So it's definite that we will need a way to we will need a way to have access to the currently executed or a work in progress fiber, something like that. So useState, okay, so let's have a function call here just before we start begin test, and it will be called set work in progress fiber. So no matter where we're gonna be throughout the whole code, we will have access as a global variable to the fiber that is currently being executed. And we can get current, get okay. So what was the name of it? Set work in progress fiber. And we can call it work in progress fiber. Okay, now we need a new folder, work in progress fiber. And here we will actually it will be everything from work in progress fiber, and we will have probably two functions here. So export const setter equals fiber, and it will do something, and we need to retrieve it. So export const get work in progress fiber. Okay, and let work in progress fiber equals null. So what it will simply do is assign it. So we progress fiber will be equal fiber, and it will simply return it. So it's just an abstraction over something. So return IP fiber. Okay. And we can even clear. So export cross clear work in progress fiber. So this way we can set it to null. Okay, so now I can save it. Okay, so now if I come to here, the problem is that there could be a bunch of use states, use effects, and all kinds of stuff here. So we need them in a block. So just imagine that if we go back to the client, actually let's create another use state. Let's create another use state. So we have counter and okay, and it will be greeting set greeting. So the problem is that we can't tackle assigning hooks and fibers in a use state or in a use effect, because there could be many hooks in a component. So we need to kinda wrap the assigning and removing of the fibers and global variables in a function that kind of prepares everything. And what I mean by that is if we go to the actual, so if we come here to the function component, so when you call this state node with the props, the problem is that just before you do that, you need to set up everything for the hooks, and when it's done you need to remove everything, like clean up every global variable assignment, because now the function call is not simply like a referentially transparent function. A lot of things will happen under the hood, because the hooks are kind of hook into the fibers, right? So the only way for them to manage state is for them to have access to the fiber. But the only way to do that is to give them access to the fiber. So that's why we created this work in progress fiber function, so it's globally accessible, but before we call the function we actually need to give them access. So work in progress, where is the hooks? So I might export const update functional component, and the functional component and it will take a function and what we can do is we can do some preparation, we can do some cleanup, and then we can actually call the function which is the way to retrieve the children, right? Like call the function. Okay, so let's import from this functional component. Update functional component, and it will take this maybe, and we can give it a return statement. So we can return something which will be the JSX, or the not JSX, the React elements. So if we give it a return statement, we can replace this fiber state node direct call with this one. Okay, so again, the reason why we need to do this kind of things, because we just can't rely on simply calling the function, because calling the function actually now calls the useState, and the useState will have to be aware of the fiber at that time, and there might be multiple useState calls or useEffects or whatever hooks we have, and they all need to be aware of what is the fiber behind the functional component. So we just can't call this update function, we just can't call the actual instance at any given time. We need to make it in a precise order. Okay, so is it working? Undefined or not? Okay, it's not working. So what we can do is, if we don't have any hooks, we can just const elements equal fn. So if we call this and if we return elements, then yeah, we are good to go. So this function is basically just calling the actual component that we declared here. So it will return this piece of JSX, and we're returning that piece of JSX from the update functional component, and from there we're giving back the control to the reconciled children, so everything goes back to normal. But we are doing nothing with the fibers just yet. Okay. Okay. So what I want to do is put it back. Actually, let's do something like let value equals initial value for now, or initial state value. Okay. Okay. So this way, if I go back here and I wanna greeting is hey. Okay. So the initial state is picked up correctly, and I can do. I just want to do this because I want to be able to test it with multiple hooks. Set greeting to morning. I know it's quite a lot, but it will hopefully get together as we start doing all kind of interesting stuff. So set greeting. Oh, okay. Set greeting. Okay. So it returns elements, which is great, and we should have access to the fiber, right? So that's the whole thing, that here we have no idea what the fiber is, and without the fiber there is no persistence. So we need to tackle the changes, tackle the state. Otherwise, we won't be able to. So we won't be able to have a state machine if we don't have a fiber. So that's the whole point of doing all this kind of, I don't know, overcomplicated thing. So I can do something like, so if I get into the update functional component, part of the preparation, so I can create a prepare hooks function, and the prepare hooks will only do one thing, which is let current fiber. It will set the current fiber to the get work in progress fiber. So now if I get into the useState and console.log the current fiber out, the current fiber should be, these should be the same, and it's good. So useState got called twice. We've got two console logs, and they should be pointing to this exact same counter. So type counter. Okay, so we have now access to the fiber. That is really good. Okay. Okay. And also we should create the clean state, so clean hooks maybe, where we can simply what we can do, we can simply current fiber equals null, and also we can have the clear work in progress fiber. Okay. So now when you run the function, obviously the function body now contains calling another function which is useState, but the useState will magically have access to the current fiber. So if you an advocate of functional programming, that's probably a nightmare, because it's anything but not a pure function. But that's not the point. The point is for the developers to have like kind of a clean interface to be able to use function with state, and that's one of the ways of getting there. So we have the current fiber. The only question is what we're going to do with them. Okay, so initial value, okay, so I did a little fix in the previous video where I renamed the pref props to and pref state to memoize state, and I believe, I might be wrong, but I believe that memoize state is a somewhat different format when it comes to functional components. So commit work. Yep. So new fiber. So we might be able to, so it's a functional component, but we don't know if it's a placement or an update. So let's just simply come here and do something like if get tag that element equals functional component, then the new fiber dot memoize state will be different structure, which will be memoize state of undefined, next of undefined, and queue of undefined. And if we state, no memoize state. Okay, so we have the memoize state on them. So hopefully I understand it right how React does it, but I think it's something like, so you instead of just, so if you have a class component, the memoize state is the previously given state to the class component, I mean to the instance itself. But in the case of functional components, memoize state will be somewhat different. Basically that's gonna be the place where we keep all of our state for future references. So obviously the current state in the current render is dependent on the previous state. That's the whole point of like a state machine. And we need some structure, and we need some place to save it on the fiber. And obviously we need to have access to it. So what we need to do is so memoize state. So whatever state we have, we need to push it onto this fiber field to memoize state. But also, since the next state, what will be calculated in a render cycle, will be dependent on the previous state, we need to keep track of them. So we will eventually have a queue. But in the initial render, there will be no queue. So we have the current fiber, and what we can do is, so that's one fiber, but as we we're discussing one functional component can have multiple use states and also multiple hooks. So memoized state is simply, and again, a linked list kind of architecture. So it has a next, and that the next will be the same structure. It will have a memoized state, a queue, and the next. So we can, so that's the way how they keeping track of the state that were rendered previously, the current state in the memoized state, or like I should rather say the last state, and we will have access to the next, which will be any subsequent useState calls. So I think if I get into the implementation, everything will be easier to understand. So we can actually call this let current hook, and so let's assume that this is the counter, like the increment part with the 0. So what we can do is, if so actually let's create a function called getNextHook. Okay, and what we need to do is, if current hook is undefined, then we need to grab the current fiber and get its memoized state, and else I think we need to get current fiber equals current fiber dot next. But if that next, so current fiber next, if it, because it can be undefined, so if it does not exist, then we need to create it in such a way that current fiber dot next will be the exact same structure, so it will have memoized state undefined, next undefined, and queue undefined. Okay, so if we get into so we prepare the hooks, we clean the hooks, and between them we call the actual function. So we now have access to the current fiber, but let's just check what we have in the current hook. It's all undefined, but if we call get next hook, still undefined, which is not good. Yeah, because I'm not assigning. Sorry. Okay, so we have current next current hook next. Just a sec. So if there is nothing there, then assign the memoized state, and if it's something there, just current hook equals current hook next. But if current hook next doesn't exist, then create it. Okay, so now what we have is we have a separate kind of linked list structure for every useState function that we have. And to make things a bit more clear, I can console log the fiber out here. So we did some modification to the fiber, so I can console log the current fiber here, and it will be more clear what's going on. So now we have the memory state here, and the memory state has a memory state of undefined and the next. So what's actually happening is that we are assigning some state to each useState function. So the first useState, which had an initial value of 0, is represented on the fiber with this memory state and with this q. And the second one, which is a string, like with a hey, is represented with this memory state next and q. And they are linked together in the exact same order as they are called in the client. So that's the reason why in the docs and in the React conference they said that don't mess up with the order, because the order is the exact representation and it's how you call in them. So if you come in here, you call the useState with the 0 first and the useState with the hey second. So we don't have any value onto them, obviously, because we haven't written any code yet, but at least now we have some fiber representation, some data representation on the given fiber for the given useState call. So that's quite crucial. But now that so it's pretty good, because we know that when we call the useState, actually if we call current hook and current fiber on inside the useState body, they will be always up to date and they will always represent the right and appropriate data that is associated with the given piece of state. So now we can start doing something like so we have the initial state. Okay, so that's good. And now we know what next is. Next is simply just a way to have reference to the next representation for the next useState. So as I said earlier, order matters. So what about memory state and what about Q? So if we the initial thing is that memory state and Q is undefined, just as next is undefined. So if they are undefined, we can assume that this is the initial render, and we can start working from here. So if current .q, so if it's undefined, then this is the initial render, and I think it's quite an easy thing to do, because what we have to do is we can assign it as a memory state. Can equal to initial state, so we know that's the initial render. And we can also start creating a queue. So on later renders, the queue will exist, so we know that that's not the initial render. So current hook dot queue will be equal to an array with the initial state. And now we can assign value, instead of being an initial state, to be simply the current hook memorized state. So that's the initial render. Okay, so we get these things, and now if I come here and go to memory state, you can see that memory state for the first useState is 0. We have a queue with one element, and that's the same for the memory state hey, and the queue with one item in an array hey. And since we only have two useStates, there is no next. Okay, and obviously we need to do something if it's the subsequent render. So I don't even know what's gonna happen now if I do subsequent render. Memory state is gone. Okay, so that's good to know. Memory state is gone, and I think that is because that is because we are not covering the state here. So memory state should be alternate memory state. So we need to copy it. Okay. Okay, now we have access to the memory state. And this is the exact same thing. So on re-render, nothing happened. Well, it was a re-render triggered by some other component. Okay, so on else, we need to do something. And let's leave it as it is now. I'd like to, so we probably need the current file, but I'm not gonna read off this console log. I'm gonna read off this console log for now and cut the video here because I think it's quite light to digest. And next time we're gonna even complicate it more with actually digging into how to set some states, sort of. So we will have our own set state implementation and then review everything so we will know how the flow goes. Okay, so thanks for listening and see you next time.